Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day to each and everyone. Okay, so ngayon ang subject na itatakal natin is actually all about CE21, no? So I think this is my first time to handle this subject, and I will try to do my best para ma-impart sa inyo, okay, ng impart sa inyo fully yung knowledge about this one, okay, about this subject. Okay, so actually this CE21 or um, environmental engineering is common for all engineering field, no? um, in every engineering field there is what we called an environment that will each field commonly encountered. Okay, so that's why no common ito siya sa lahat ng mga fields ng engineering. Okay, we are actually handling some focuses on those field, no, focuses on on different fields. Okay, by considering the environment we are having on that field. Okay, so yun, kasi kung hindi natin i-consider yung environment natin while we are implementing the engineering fields, okay, ang tendency is that um, hindi magiging effective yung ating implementation of rules and laws and theories na naintindihan natin sa ating engineering studies. Okay, so yun, so that's why we need to know about the engineering fields as well. Okay, so now once again, this is CE21. This is week 1. Our topic, these topics is good for only week 1, no? I thought we also started our um, semester, no, exactly on June 21, and this week 1 will end on June 26. Okay, then after that next Monday naman is yung week 2 na naman natin. Okay, by the way, so this is introduction of environmental engineering. Okay, so once again, ang pag-aaralan natin dito is all about environment, no, with regards to the fields of engineering. Okay, so yun. Okay, now what will be the learning outcomes, no, when we have already have this subject, no? The first one is describe what is material science, no? So determine its applicable engineering, discuss and explain. Okay, yes, tama. So yun, so yan. Okay, so we are actually ang pinaka main na concern natin dito is actually the materials or tools that we are using, no, in having our fields. So yun, so we also know that in every materials it's composes of atomic structure, so that's why we have also have to we have also need to discuss the atomic structure and then in the interatomic bonding. Okay, so yun. So now mass and energy transfer. The first one here is the mass. Our topic for this one is mass and energy. The first topic that we have handling this right now is mass and engineering energy transfer. Okay, so it's because in this once again, no, okay, sorry for that, no, ito pala is mal ito siya. Okay, hindi ko pala to na-edit. Okay, so anyway, tama naman yung sinabi ko kanina, no, this is actually related with our atomic structure, but this will be the main this will not be the main learning outcomes. Hindi ko to na-edit actually, para to pala sa material science, no, sorry for that. Okay, so ang pinaka main concern natin dito sa energy or environmental engineering is the energy or the parameters that is actually connected with the matters that we are handling, no, that, right, like for example, if we are, di ba, we are concerned with the environment here, no, most probably we are concerned with the pollutants, no, that we are experiencing right now, no, in our daily life. Okay, so we know that when it comes to the pollutant, no, it is actually composes of an energy, no, na nagpapa-expand doon sa pollutant na yon. Okay, so it cannot actually travel from one place to another. Okay, or let's say for example yung amoy ng isang basura, hindi yan siya pwedeng mag-travel from one place to another without energies. Okay, so yun, so that's why in here we need to consider the mass and energy transfer. Okay, i-apply natin yun siya pagdating actually ng ating main topic. Okay, since we are consider here the energy transfer, environmental energy. Okay, engineering. So the first one here is the unit of measurement. So I will let you to have this, no, on your own kasi alam naman natin to lahat, no. Most probably we are using international system of units. At the same time we are also using US customary system. Okay, so yan, dalawa yan sila. So ito yung table, so you can refer this one. Okay, okay, now by the way, every time na we are considering the mass or the uh, mass or the uh, ano yun, system itself, okay, we are actually referring to the uh, pounds per ano yun, pounds per parts per billion. Okay, kasi in here, since everything surround us is an actually environment, so therefore one of our measurement actually that we are using is by weight, no. Yan yung tinatawag nating pounds per parts per million. Okay, so anyway, may mga conversion naman dito, so you can actually refer this. Just like for example, this 1 milligram per liters is actually equal to 1 gram per meter cube, or it is equals to 1 ppm or 1 parts per million. So itong mga conversion na to rito is pwede natin yun siyang gamitin sa conversion natin or sa pag-identify natin kung ilang parts per million ba yung ating i-consider na mass. Okay, so now, so for example this one, no, meron tayong fluoride concentration in drinking water may be increased to help prevent tooth decay by adding sodium fluoride. However, if too much fluoride is added, it can cause a discoloring, mottling of the teeth. The optimum dose of fluoride in drinking water is about 0.53 millimole per liter. If sodium fluoride is purchased into 25 kilogram bags, how many gallons of drinking water would a bag trade? Okay, so yun, so in here we are considering about the mass of the system, mass of the substance, no, na kinonsider dito sa problem. Then after niya makuha yung force or yung kanyang mass F, so sa kanya kukunin yung concentration. So just refer on the calculation here kasi detailed naman to siya. You can ang pinaka consideration lang na dito actually is to find out the volume na involved doon sa kuan natin, since we are considering the substance here. Okay, so yan. Now gases, dito naman tayo sa gases. Syempre, no, gas is also a part of environment, so that's why we need to know about the gases, no. But usually when we are talking about gases, it is all about the PV-nRT or the IDR, or what we can all use, no, directly is the what we called the ideal gas equation. Okay, so since we are talking about gases here, no, kasi lahat ng mga studies natin actually all about gases is we can actually refer on the ideal gas equation. Okay, so that's why in here we need this equation 6, which is PV is equals to nRT, where R is the ideal gas constant. Okay, so yun. So we have also an equation, an example here. So you may just ito gagamitin lang natin dito is yung ideal gas equation. So yun. And then after that, kukunin natin yung parts per million niya. Okay, that just convert it using this conversion here, yung pinakita ko sa inyo kanina. Okay, ko-convert lang niyo yan siya. Ito. Okay, this one. Ito. Okay, so yan. Okay. Another problem na naman dito. Ang kukunin natin dito actually is yung same. Express the standard as a percent of per volume as well as in milligram per meter cube at 180 m and 25 degrees Celsius. So, same pa rin. Ang gagamitin natin, kukunin muna natin yung yung ratio ng mass per volume. Then, after that, kukunin natin yung standard percent of volume. Okay? So, yan. Ayun. Makukuha pala natin yung standard percent bago yung milligram per meter cube. Okay? So, yun. So, yun. Ito yung pinaka-main na conversion na pwede natin gamitin. Okay? Okay, so yun. Pag hindi given yung, or pag hindi sinabi na required yung conversion yung sa una. Okay, so yan yung pwede natin gamitin. So, I thought this will end our discussion for this week 1, no? Just review or just read this as a whole para mas maintindihan natin, okay? Kasi maliit lang yung time natin, so I will leave you uh, be what will be the idea about behind this subject, behind this topic. Okay, so ang sa akin lang is to give an overview about what we can learn about these topics. Okay, so again, that's all. Assalamualaikum warahmatullahi wabarakatuh.